Shotgun ballistics is an important part of ballistics. Shotgun is a smooth bore weapon. Its diameter is the same at all places. Shotgun are smooth bore weapon. They do not have lands and groove. They are called shotguns because they shot one ball or a number of pellets in the cartridge case. These pellets are made of lead and the shotguns are categorized for their bore. There are different bores of the shotguns varying from up to 32, from 8 to 32. The 12 bore shotgun is a very important firearm and is in the category of shoulder firearms.
Learning outcomes. Dear student, after studying this module, you shall be able to know about shotguns and its ballistics. You'll also have a brief introduction to the mechanism of shotgun, and you'll learn about factors involved in the shotgun ballistics. Let us start with introduction to shotguns. Shotguns are smooth bore, that is, they have a smooth barrel. Now, they generally fires multiple projectiles called as pellets instead of a single projectile as in case of rifles. However, some shotguns are capable of firing single projectile known as slugs. Shotguns can be either single-barreled or double-barreled. Further, the single-barrel shotguns can either be single-shot, pump action, or automatic. Here, pump action is by which a slide under the barrel slides along to put another cartridge in the chamber, whereas the double-barrel shotguns can have their two barrels either adjacent, that is side by side type, or one on top of the other, that is over and under type. Swan-off shotguns have their barrels swan short so they can be carried more discreetly. They are also less accurate. Usually, a shotgun is a short-range firearm because of the dispersal of the pellets at certain distance, resulting the decreasing of its effectiveness for long-range targets. However, it is highly destructive at short ranges, though it is almost ineffective beyond 100 meters. It ordinarily fires a number of projectiles which spread in an increasing area with increasing range. The aim, therefore, needs not to be critically accurate. Now, let us have a look on shotgun ballistics. Shotguns are designated by the size of the bore. Thus we have 8 bore, 10 bore, 12 bore, 16 bore, 20 bore, and other bore guns. They have varying diameters. The 12 bore shotgun is the most popular shotgun. It strikes a balance between the weight and the effectiveness of the weapons. Formerly, it was believed that the length of the barrel adds to the wounding powder of a firearm. Most of the shotguns, therefore, had barrels over 90 centimeters. A lot of research and experimental work has proved that the combustion of the propellants is most complete with short barrels of 40 centimeters. There is no material difference in the velocity and hence in the striking power of the projectiles when the barrel length was reduced. Now, most of the shotguns have barrel length less than 75 centimeters. The following features are important ballistically. Shotgun cartridge. The cartridge of shotgun is unique and not as same as normal cartridge of rifle firearm. Here is a diagram showing a shotgun cartridge. Unlike a rifle cartridge, which is a pointed one, a shotgun cartridge is a barrel-shaped structure having compartments for containing pellets and propellants separately. Three types of wad present in shotgun cartridge, which are overshot wad. This wad prevents the escaping of pellets from the uppermost crease of the cartridge. Number 2. Undershot wad. This wad is placed just below the pellet for the same purpose of preventing leakage of pellets. Number 3. Air cushion wad. This wad has a most important role in a shotgun cartridge as it checks the escaping of gases produced by the burning of propellants. Number 4 is overcharge wad. This wad is placed over the propellants in order to prevent the movement of propellants from its compartment. Let us discuss firing mechanism of a shotgun. A shotgun has a most simple mechanism which contains very basic but important parts which are barrel. Barrel of a firearm is one of the most important parts which facilitate the movement of the projectile. It also provides a space for the expansion of gases. The barrel of shotguns are smooth bore, that is, no rifling. Number 2 is chamber. Now, chamber is present at the breech end of the firearm, where the cartridge is housed. The cartridge rests in the chamber and trapped by its rim. Third part is bore. It is the number indicating the size of the internal cross-sectional diameter of the barrel, that is, the number of spherical lead balls exactly fitting inside the barrel and together weighing exactly 1 pound. Then comes choke. It is a depression at the muzzle end of the shotgun produced in order to decrease splattering of pellets and increase their range. After choke comes action. Action of any firearm consists of mechanism for loading of cartridge, firing, extraction and ejection. Then comes stock. Stock of a firearm is a part which support and hold the internal parts in position. And last would be firing pin. It is a pin-like structure which hits the percussion cap of the cartridge case when the trigger is pulled. Now let us see what is a recoil. Recoil is the forces acting on a fired weapon which cause a handgun to either gently rotate in the hand or violently bite into the palm, or a rifle to gently push against one's shoulder or produce a bone bruising kick. Recoil is an important factor controlling the construction of a shotgun. When the recoil velocity is less than 3 meters per second, the recoil is not troublesome. It is tolerable up to velocity of 4.5 meter per second. It becomes intolerable beyond 5.5 meter per second. The recoil velocity permits the calculations of the desirable approximate weight of a shotgun, that is, backward momentum is equal to forward momentum, which is V into m. Here V is equal to muzzle velocity while m denotes weight of ejector. After putting the value of muzzle velocity and weight of ejector, we get 400 into 35 by 1000, which gives 14 units. If weight of the gun, which is W, is to be found when the velocity of recoil is 4.5 meter per second, the velocity which does not give gun sickness, we have W into 4.5 is equal to 14, or W is equal to 14 by 4.5. That will give 3.1 kg, that is similar to 3 kg. So we have the weight of the gun. Now lighter guns are becoming popular. They give either greater recoil or the charge is reduced suitably to bring down the recoil. The recoil, however, can be reduced by a suitable compensator. The heavier guns are going out of fashion and they are on the way out. Now let us see jumps and vibrations. The jump and vibrations in a shotgun may disturb the aim. They have to be controlled. When a gun is fired, the breech jumps upward. Consequently, the muzzle tips downward. By the time the projectile charge reaches the muzzle, the reaction wave vibrations push the muzzle somewhat upward and the projectile theoretically strikes the target at a slightly higher point than the bull's eye. Ordinarily, the change is only slight and it is compensated. In double-barreled guns, there are sideways vibrations also. The time interval from the pressing of the trigger to the ejection of projectiles in shotguns is about 0.008 seconds. The personal factor, therefore, matters little unless the person is nervous. Contrary to popular belief, heavier guns are steadier than the lighter ones. Now let us discuss pellet spread patterns. The important fact which distinguishes a shotgun from any other firearm is the spreading of pellets, which gives a greater coverage of the target area. The area goes on increasing with the increasing range. Thus, the aim is not so critical in shotgun shooting as in the case of other firearms. The spread of pellets varies not only with range but also with the choke characteristics of the barrel. The choke not only reduces the spattering but it also makes it more uniform. The effectiveness of a pattern is also studied by its density. It is expressed in terms of percentage of the total number of pellets falling in a circle of 75 centimeters diameter at a range of 36 meter, that is 40 yards. Comparison of the densities with various chokes of a 12-bore barrel are given. Here you can see percentage of the pellets in 75 centimeter circle at various ranges. Now this is range in meters with full choke, half choke, quarter choke, improvised cylinder and through cylinder. Similar densities in the patterns given by guns of different bores can be achieved by having choke characteristic and different loads, as it is shown in this chart that has bore, choke and different load. Now let us discuss about the strength of the firearm. Pressures developed affect the weight and the wounding power of a shotgun. Higher pressure means higher velocity and consequently greater wounding power, but the thickness of the barrel walls and the strength of the action of the firearm have to be increased, increasing the weight of the firearm also. A modern 12-bore cartridge develops a pressure of about 550 kg per centimeter square. It is almost twice the pressure developed by a gunpowder cartridge. The shotgun, therefore, meant for gunpowder cartridge, cannot be used to fire cartridge containing smokeless propellants. The barrel wall of the shotgun cannot be made very thick as they will increase the weight. Higher velocity for the charge has therefore been achieved through progressive powder. They give sustained pressure and consequently increase the muzzle velocities without increasing the peak pressure. Then comes stringing. The stringing of pellets is an evil in a shotgun fire. In the stringing process, the pellets do not travel in one plane. Instead, some of pellets follow one behind the other in a string-like fashion. The normal string length of the most of the charge is roughly 15% of the range. However, the first and the last pellets may be almost one-third of the range apart. Progressive powders reduce the length of stringing to about 10% of the range. The use of sleeves of the projectile charges has reduced the stringing length considerably. Long strings are undesirable. Shorter strings increase the wounding power. The main cause of the stringing are unequal sizes of the projectiles, unequal friction, and different extent of the deformations of the projectiles. These factors cause the velocity difference in the pellets of the same cartridge and cause stringing. The number of pellets lost to reduce the density of the patterns is dependent upon the range. For full choke, the loss in density is about 5 and 15% at 30 and 40 meters respectively. Now let us have a look on wounding power. A firearm projectile acquires its wounding power from kinetic energy it possesses at the time it strikes the target. It is given by the formula Ke is equal to half mv square. The most important factor in determining the kinetic energy of the projectile is its velocity. The table below gives the striking velocity of the pellets of different sizes at various range. Now, striking velocities for a standard 12-bore cartridge is somewhat like this. It has been estimated that a bird game needs a transfer of about 0.11 meter per kg, that is 0.8 foot-pounds, energy to ensure a kill. This is a rough estimate as it is not possible to assign any definite value. The value will vary with the sight hit and from one game to the other. It is, however, a useful value for comparison purpose. On the basis of this figure, it is possible to calculate the minimum effective velocities required by the pellets of various sizes. Now, this chart shows minimum effective velocities for kill. The energy required by a human target to be put out of action is given to be about 5.5 to 8 meter per kg. Therefore, the energy transfer required is about 50 times or more for human target. Thus, if one small pellet can kill a bird, about 50 pellets are required to kill a man. It is in this context that the shotgun is termed only a short-range firearm. Only at short range a number of pellets can hit a person. Most of the shotgun cartridges manufactured give muzzle velocity close to the velocity of sound. Consequently, the striking velocities are usually in subsonic zone. The rate of loss of the velocities, the loss is due to air resistance. The retardation due to the air resistance are already seen is considerable. In practice, it has been observed that if the muzzle velocity of a number 6 projectile is increased by 40 meter per second, then the net gain in the striking velocity of the shot at 50 meters will only be 13 meter per second. Another factor is poor form factor. The shotgun projectiles are mostly spherical in nature. They are notoriously poor in retaining the velocities. The ballistic coefficient, which measures the ability of a projectile to retain the velocity, as seen already, is given by C is equal to W by D square N, where the value of N for a cylindro-conoidal bullet is 1. It is 2.3 for spheres. Here is a chart showing ballistic coefficient for the various shot sizes. The third factor is the size of the pellet. The rate of loss of velocity is also controlled by the size of the projectile. Smaller the size, greater is the retardation. Thus, the number 2 pellet retains lesser velocity than the LG shot. The former is more or less harmless at 100 meters. The latter is dangerous even at 1000 meters when fired at an elevation of 30 degrees. A single projectile fired from a shotgun is still better in retaining the velocities. However, they suffer from the other defects, that is, 10 cartridge fired from a range of 30 meters will cover an area of more than 1 meter square at the target. Fourth factor is the cylindrical projectiles, especially those given spin, as already seen, are accurate for a much longer distance and lose velocity at a much lower rate. Number 5. The following factors also affect the velocities of shotgun projectiles. The effects are of theoretical interest only. Number 1. Barrel length. If the barrel length is below 40 cm, the muzzle velocities are low. If the barrel length is more than 40 cm, the gain is only marginal. There may again be reduction in the muzzle velocities if the barrel is too long. Number 2 is choke. A full choke barrel increases the muzzle velocity by about 6 meter per second. Number 3 is weight of the charge. If the charge is decreased by about 2 grams, the gain in the muzzle velocity is about 20 meter per second. Fourth is shot size. The smaller sized pellets acquire greater muzzle velocities. Fifth is density of loading. It may give difference in the muzzle velocities up to 20 meter per second. 6 is progressive powders. They produce better velocities for the same pressures. 7 is bore diameter. For the same pressure, the projectiles in a large bore have greater velocities. Then comes the extreme range, which is denoted by R. Extreme range of a shotgun projectile fired at 30-degree elevation can be calculated by R is equal to 1500 by n raised to the power 1 by 3. Here R is the range, n denotes the number of pellets per 28.35 gram. Another simple formula for extreme range is R is equal to 2200 into dp. Here R is range in yards, while dp is pellet diameter. The reduced velocity, which is denoted by Vd, of a spherical ball of ballistic coefficient, which is denoted by C, with a muzzle velocity Vo at a distance d is given by d is equal to C into log Vo by Vd. Now let us summarize this chapter. Dear students, in this chapter we have learned that a shotgun is a short-range firearm. It is highly destructive at short ranges, though it is almost ineffective beyond 100 meters. We have also come to learn that pressures developed affect the weight and the wounding power of a shotgun. Higher pressure means higher velocity and consequently greater wounding power. The barrel wall of the shotgun cannot be made very thick as they will increase the weight. The spread of pellets varies not only with range but also with the choke characteristics of the barrel. The choke not only reduces the spread but it also makes it more uniform. Along with it, we have come to know that in the stringing process, the pellets do not travel in one plane. Instead, some of pellets follow one behind the other in a string-like fashion. A firearm projectile acquires its wounding power from kinetic energy it possesses at the time it strikes the target. And we have learned that the rate of loss of velocity is also controlled by the size of the projectile. Smaller the size, greater is the retardation.